Hello and welcome back to Calculus 3, section 11.9, curvature and normal vectors. So, where do we start? We would like to quantify curvature to assign a numerical value in a way that the larger the bend, the larger the number, and the closer to the straight line it is, the number would approach 0. So when you have a 3D wire in space, or if you have a road, right, mountain road or whatever, different sections of the wire or the road will have different curvature. So whenever you have a sharp bend, like here, sharp bend, that should be large value in terms of a number. And then in these flat areas could be small value or 0 for straight lines. And we're going to build that formula. The interesting part, at least to me, is that we use one formula to understand the concept, and we use a different formula to do calculations. So that's, I don't know, that's interesting to me. So let's see. First, the unit tangent vector. That's the review. We can put that as a t hat, right, unit vectors. And if you remember, that was your r prime of t divided by the magnitude of r prime of t. Now this r prime was velocity. The r, so this r prime is the derivative of r. In respect to t. And that would be the derivative of the vector fgh if you have the 3D, right? So now, we have a curve of some kind, and we introduce these tangent vectors. Now these tangent vectors are going to show us the direction of motion. I understand it's a grim example, but it's an example. We're talking about the roller coaster, right? And at one point it derails, right? So which way it's going to go? It's going to go in the direction of the tangent vector. That's what the tangent vector can show. The magnitude of the tangent vector will tell us how fast it's moving, but we are generally interested in the direction for purposes of building other formulas. So we keep that down to a unit. So I'll put these hats on these vectors because these are unit tangent vectors. Now obviously, as we are working with application, right, they will have magnitude other than 1. So at each point, you will have this tangent vector at each point of the curve. Now, a segment of this, call it delta S, would be the piece of the arc length. We know that there is the length of the entire curve, right? So we can just observe a small piece, delta S. Now, how small it is? Infinitely small. as small as we want. So we can describe the curvature as the change of the tangent vector, unit tangent vector, in that little interval. So it's very difficult for me to draw with a great precision here, but these two tangent vectors are not the same, as you can see. Over the small arc length here, as this tangent vector moves from one point to another, the direction of the tangent vector will adjust. So, because you are computing the tangent vector at a different point in time, right? We know that everything is in terms of parameter, lowercase t. You can think of that lowercase t as time. So to get this vector as, I don't know, 1, 1, 2, and then this one 1, 1, 3, say, there's all other ones in between. So as you're adjusting that little t that gives you different instances of this vector along the line, you see that you can measure the curvature here of how curved this piece is by simply figuring out the derivative, the arc length, right, in respect to the arc length. So we are going to define the curvature as the change of the unit tangent vector in respect to the curvature. So that's only to understand what's happening. But in terms of calculations, we are going to use something that we can easily compute. Yes?
What did you say delta F1?
I'm sorry?
What did you say delta F1?
Arc length, small piece, like delta x, right? It's a small piece on the x-axis. Delta s is the small piece along the curve. I woke up this morning with nose being really annoying. The hell? There we go. What happened? What are you doing? So no one knows in the area. Okay, that's fine. Does anyone have duct tape in the classroom?
Oh, I wish I had.
Super glue would work as well. All right. So we have the basic understanding, and I'm going to say that the curvature k, lowercase k, is going to be the magnitude of the change, the unit tangent vector in respect to the arc length. Now, we can manipulate this formula a little bit by dividing the top and the bottom by dt. And we're going to get the form that we could actually use to compute. Now we know that the magnitude of v is the good old r prime. So the actual formula, I'll write it in blood here, is k equals the derivative of the tangent vector, which is this part, right, divided by r prime of t. Now we have magnitude in the numerator and denominator, which means that the curvature is going to be a number, like 7 or 0.3. And that's the curvature formula.
Should there be the little hat on top of that piece or not?
Sure. Here are the hats and arrows. Yes?
Why is 1/v R3?
Meditate on that one.
What?
Meditate on that one. When you get a chance. Question is, where is V coming from? So we have this is that, and 1 over is this one. And yep. Well, it's a magnitude velocity in this case. When you write it this way, it's speed, right? Now we all know that the speed is connected to the curvature. Example 1 says, I think, that straight lines have 0 curvature. Is that true?
It depends on who draws them.
A straight line is a straight line.
Yes, straight line is a straight line. So, all right, can anyone tell me the formula for straight line?
Y mx plus b.
In 3D?
Y equals
Why equals
What do you want to do?
R equals
you have one of the
We could do that.
can't you say that like one of the low values has to be
No, it's a great thing that you guys study this stuff. I mean, it's not that it's ever going to be on a test or something like that. We're going to bring in crocheting and things.
hey,
It's an art, yes.
oh, also that.
I know. It's amazing, right? It's amazing what I know. So straight line is going to have that initial point in space, which is x0, y0, z0. And then we are going to have a vector, ABC, which carries the three-dimensional steepness, right, slope, in time. So as you can see, each one of these is technically y equal mx plus b. So compute the curvature for general case. What happens? Knowing that A, B, C are constants. Do what? Yes. How many derivatives down the line do you go? Don't you go 2 derivatives? You have r prime to make capital T, but that's a T prime. So when you take, it should be clear, I mean, it's Calc 3. When you take the derivative of this for the first time, only A is going to survive, right? And that's just gonna make T. And then I have to take one more derivative, this one, and it kills that. So you just get 0 across the board. So the curvature of the straight line is 0, which makes sense. So to create unit tangent vector T, we are going to take the r prime, which is ABC, and divide that by the square root of A squared plus B squared plus C squared. That is now unit tangent vector for a straight line. And then as soon as you find T prime, A is just going to be, I'll put the magnitude is 0, which implies that the curvature is 0, which makes sense. Again, it's a straight line, it's not curved. They also have a formula for a cross product. Look at it and then just move on. Well, actually, no, I'll write it because you can. Then you pick which is easier for you. I've never used this formula, to be honest with you. So it's the curvature formula, alternative curvature formula, given through the cross product. Yeah. But it can be done. Hate yourself. It's going to be a very dark and negative class today. We are already, I mean, you started it, so. Didn't you open up the class with a statement?
Oh.
It's a fundraiser, so just $1, that's all.
You go.
I'm broke. Is that old?
All right, so you're all sitting there with nothing to do. Let's find a homework example you guys can enjoy. Exactly, Chewy.
Is this the fundraiser jar?
Oh, nice.
Is there anything on it?
I'll have to find out.
Is there like 5 cents on it?
You'll have to find out.
So there's R. I will write the formula on the board. These calculations can be long and messy. No coffee.
Where do we find it?
Curvature.
At any specific point or at all points?
You will get the function and then you can. Oops. All right. Just the whole thing. Yeah, and then you will get it as a function in terms of t, and then you can plug in t equals 1, t equals 7, whatever is required, right? What's the curvature 7 seconds into a trip, right? You have the particle moving on the.
But somebody like it help us. Oh, that's what.
So what part's the magnitude?
Oh, this is kind of a fun square. The worst part about it is just calculus. What else?
I feel like I just
So much love and respect in this class. It's amazing. That's how I create learning communities. One time.
Okay. I just
What? I'm allergic to someone in this class. I gotta figure out who it is. That person is out. Like, I have no allergies when I go in the other class. Oh, wait. I was allergic to you yesterday. Yeah. So you guys.
You would have thought it's not me. You would have thought so.
That's different.
Thanks.
Some point just want to be back with you. You too. March 12th. Yeah.
I'm going to see you like cheese. And I did shoot you, didn't I?
You took the magnitude at the top of the bottom. Yes. Has to be a number divided by a number to give you the number. Oh. I know. Aren't we all? Sculpture. Fun.
Don't go that out.
So what now?
The donation.
I'm working on it. This one? Sorry, yeah. Skip the magnitudes. This one, that. Right? I'm like, unless I'm missing something.
And then you find.
So I found the derivative, and then I found the derivative of that. That's gonna be the numerator, and that's the denominator. No, it's not. Okay. I might be missing something.
Yeah, that's like what you take the derivative and then you take that basically plug that for the numerator and then the denominator is the square root whatever, but now you have all this, you have the square root of that.
That's not what I would have done. I remember you told you to never do that until you found out what you were doing.
If capital T is a unit vector, isn't its magnitude always going to be 1? So we don't have to do that every single time? Oh, wait, no, because we have to derive it.
You have to get it, yes. So you have to do it every single time. Which is exactly the thing I did. So here's your checkpoint for T hat. You all have the same?
Yeah. I'm staring continuously. I know. I'm frowning because I understand what you did. And I'm upset that I didn't do it.
Oh.
I hate damn it. No help.
Are they all going to be this nice? Really?
Yeah, those first three are homework. And then after that, hell breaks loose. Like for example 4, good luck. Yes?
As long as I try not to. What? That's not that either.
It's clearly 1/2.
Obviously. Oh. Stop.
Calculation.
So just give us the magnitude of T. T always going to be 1. So it's going to be magnitude of T times the window.
I just don't like to calculate completely.
Right. So that was a 3D example. How about we do a 2D example for curvature? Wanna try use the cross product one for that one? Why not? Because cross product cannot be done in 2D. Very good. All right. I know. I did my best. Here. So, I mean, I should have done it, the 2D example first and then 3D, but then the 2D example looked like this. So. So you just see it from here. Don't have to write anything, right? ln, so it's going to be sine over cosine tangent. So it's 1 comma tangent divided by 1, and then you differentiate that. Okay, 1 comma secant squared divided by 1, and at the end. Okay. Ln function. And the denominator for r prime would be 1 plus tangent squared, which is secant squared. Right?
So wait, what was the final?
I will write it out because I have nothing else to do.
I like illustrations. Yeah, oh, and fun colors.
Illustrations and fun colors, okay. So the derivative, right? Derivative of, yeah. Negative tangent, details. And then the unit tangent vector. Divided by the secant, right? Because it's the square root of secant squared from the identity. So the unit tangent vector is 1 over secant is the cosine. And this is negative sign. It is a unit tangent vector because when you square both of them, you get square root of 1 is 1. And now for the curvature, we take these derivatives. Magnitude of that, which will be 1. And then secant t. So it's cosine t. You provide the t time, and you will have the magnitude, the curvature. Can anyone confirm this result? Yes? All 3.4 of you? Nice. Well, many people are actually. Terrible.
So could you do that in your head? We don't want to know what happens to yourself.
I missed the minus sign. So no, clearly no. I'm incapable. That's the first half. Second half is the principal unit normal vector. So for the curve, we said that we're going to have at the point unit tangent vector But then we're also going to have the unit normal vector. Unit tangent vector and unit normal vector are always at 90 degrees. So the dot product between them is 0. Good. They're both unit vectors, which means they get those little hats. Magnitude is 1. And the normal vector is the carrier of the acceleration, inward acceleration. You can see that it points towards the center of the curvature.
So if it points towards the center, if that curve started going left or up.
Very good. Very good. So at this point here, unit tangent vector might look like this, but the normal vector will go like that. Nice. That's the formula. And all you need to do now is enjoy an example, because you love this stuff.
It's a strong word. Yeah.
Isn't that the same thing as curvature?
No.
Curvature right there.
Oh.
It's a tangent vector to a tangent vector.
Yeah, same thing.
So let's start with a 2D example and then transition into 3D example and then transition into the cars to go home. Sounds good?
Yeah. Are you going to give a study guide to the test?
Do you need one?
I prefer it.
Okay.
Probably just like the air.
I'm trying to know what the theories.
While crocheting in Calculus class. I'm actually going to take a picture of you crocheting because one of my colleagues will not believe me.
What? They probably will. I crocheted during the Galileo scholarship meetings.
I'm going to lose that one.
Write it down and throw it back.
Is that how you're planning on cheating? Because for the test, because I can see it.
What then?
You didn't have curvature written down in your notes.
No, I written down. I had it written down wrong.
Here, do it on the board.
I was waiting for an example. Like, you just show us an example.
That's an example. Well, it's just drawing.
Yeah.
Find R prime, find T prime, put them all together. If you're done with this, you can go an extra step and show that the dot product between P and N is 0. You know, so you really run out of things to do when you do that.
doesn't have to be that.
Now let's see the dot product.
Is this the final one? That's what you said.
It's a vector, right? Now the dot product is this one. And no, and T. I think. Well, they killed the physics once they took the land down. I understand it. You should just scream, use the trophies. His bird stuff. No, Becky, my day. Make sure all the dancers, you know, fan and happy, and then they go into the area. Yeah.
So as you can see, most of this stuff is just plug and pray, right? Yeah. So R prime is 2t comma 1. Sometimes this pen. So that's the R prime, 2t and 1. The unit tangent vector is going to be 2t 1 divided by the magnitude. And what's the magnitude? Good. Now what? these wonderful 2D examples, right? So, what now? Well, we take the derivative. We have the quotient rule. So that's 4t squared plus 1. Square root of 4t squared plus 1 times the derivative of the top, which is just 2, minus 2t times the derivative of this, which is 1/2. The 4t squared plus 1 to the negative 1/2. That's the first one. What happened? You mean 8t? Yeah. This one right here. Better? Awesome.
Can you just do the product rule with the integers? Would that make it easier or harder?
Same, because we still have to fix it.
Oh, yeah. I didn't get that part, though.
And hopefully we can all agree this is not hard at all, it's just annoying as hell.
Yeah.
That's the difference between hard and annoying. This one is just 4t, I'm just going to do it on the side, plus 1 raised to the negative 1/2, so it's negative 1/2 to the negative 3/2 times 8t, so it's negative 4t divided by 4t squared plus 1 to the 3/2. I mean, it's really ugly, but what can you do? So now, some things drop, and if we are to multiply by 1/2, that will cancel the 1/2 on the second term. Multiply the 1/2 in the first one, so it's going to be 2 times 4t squared plus 1 minus, so gone, 8t squared. At least they have the same denominator. So 4t squared, that's going to drop, so it's just 2. And on the second one, negative 4t. So that's d prime. And all you need to do now is to find its magnitude. And you're done. right? You put it together and done. Yes?
So, are these, is this a unit vector, right? It's a unit vector.
Yeah.
So you could multiply by like 4t squared plus 1 and then the square root of 4t squared and it would cancel everything out, wouldn't it? You'd have the same answer.
You could what? Multiply?
So like the top t hat,
Uh-huh.
if you multiply by, because it's a unit vector, so you can multiply by the square root of 4t squared plus 1 and the square root of 4t squared plus 1, so it cancel out the denominator.
You can't because it's not an equation. You have only one side. It's expression. That method works with equations only.
So how did you get
Uh, so you have this guy, right? So you multiply top and bottom here by 4t squared plus 1 to the positive 1/2. Now, positive 1/2 means a square root, so square root times itself, no square root. It was positive 1/2, negative 1/2, they cancel out. So you get this, right? And over here you have the p, right, negative p, and at, negative at squared. Distribute this one, positive at squared, dies with that. And then well, that's how they make us. Magnitude, that's all we need, right? I can sense some pain, but you guys got this. And again, so the square roots in the denominator, the denominators, right, 3/2, the halves drop because of squaring, and you are just left with, in this case, 4 over 4t squared plus 1 cubed, and in this case, 16t squared over same. So now that you have that, you can put them together because it's under square root, right? Okay. So what is t prime? So magnitude of t prime is, you have the fractions above, oops, I have lost my ability to write. There we go, finally. And the denominator, we can factor out the 4t squared plus 1 cubed. Put that in front of the integral. The square root. So what do I have? I have square root of should throw in some short commercial breaks. That should be a t. So those squares will cancel. We still have plus in between them and the square root. So these guys cancel. They go in front. We get 1 over 4t plus 1 to the 3 halves. And that's a 4. The what? Plus 16t squared. 4t plus 1 to the 3 halves. Again. So now, do they all drop? Do they all drop? No. Yeah, I did it illegal thing. There we go. Now it's not over 2. You can always make it better.
That's N, right? Not, that whole thing is N.
M?
N,
N? Yeah.
so normal.
No, this is just that's the magnitude. Then you put them together. Oh. Yes. Thank you for pointing that out. I'm already dividing by the magnitude.
Actually, you're not wrong if you do that. It's just not even.
No, it's just a lazy way out. That's what it is. It's actually simple to simplify because you will multiply with the 1 over root. You will cancel in these two cases, and if 100 goes the root, it will pick up on the second order and cancels there as well. You're not going to get a beautiful thing, but it works. All right, so what else is there? Then they get into these really specific formulas in terms of acceleration in component form. And I would say just don't worry too much about that. Technically, that's all that I wanted to cover in this one. Questions, concerns? No? All right, stop the stream and we might restart.